morning friends, welcome to Active Learning Video Lecture Communication organized by Gujarat Technological University at BISEC. I am Silavat Mohammed Rahish and my topic is electric field and capacitors. I am lecturer at Gandhinagar Institute of Technology. Basically, electrical engineering is a vast and very giant field which includes power system, electrical machines, electrical machine design and many more subjects. But before going to that subjects, electric field is a very basic thing, so we should know what is electric field, and after that we can move to the other subjects. So today we are going to see electric fields and capacitors. First of all, we will see the part which will be covered in this lecture. First of all, we will see what is electric field. After that, electric flux comes. What is electric flux and its applications. After that, we are going to see electrostatics, the definitions of electrostatics. After that, we will see the fundamental laws of electrostatics. Then we will see what is electric charge. After that, we are going to see characteristics of electrical lines of force. Then we will see what is electric field intensity. After that, we are going to know about electric field intensity. There is relation between electric field density and electric field intensity, so we are going to derive the relation between density and intensity. And then we are going to see electrical potential. So this is our electrical field. After that, secondly, we are going to see capacitors, because we have heard about capacitors and it has many applications. So we are going to see capacitors. First of all, we will see introduction to capacitors. It means what is capacitor. After that, we will see dielectric materials which is used in a capacitor. Then we will see the structure of capacitor, how it is formed. After that, we will see what is capacitance. Then we are going to see different arrangements of capacitor. It is having many arrangements, so we are going to see that. Then we will see the capacitance of a parallel plate capacitor. After that, we are going to see capacitors in series. It means which formulas are there for capacitors in series, and then capacitors in parallel. And finally, we are going to see the applications of capacitors. First of all, electrical field. So what is electric field? Electric field is nothing but basically a region surrounding a unit positive charge or a unit negative charge, and the effect of the charge is experienced. That is called as electrical field, or it is also called as electrostatic field. The electric field around a charged body is represented by imaginary lines. Friends, these lines are totally imaginary, and if you have seen the magnet, so magnet is also having imaginary lines, and electrical field has its own lines. Here you can see that a unit positive charge is taken and the lines are there, and that is known as electrical field imaginary lines. So it is having an electrical field. The unit positive charge is having an electrical field around it. So this field will always be under stress. Now what is electric flux? If you have refer magnetic circuits, so there we have magnetic flux and here we have electric flux. So what is electric flux? So electric flux is basically defined as the total number of electrical lines. Before we have seen the electrical lines of force, so the total number of electrical lines of force passing through a given area in the electrical field. The lines of force are emanating from a charge and it is always at right angles to the charge. So the electrical flux is basically a total number of electrical lines. And here one thing, the unit of electric flux is coulomb. Friend, it is very important thing that we have to know all the units of different quantities. If we are having an example, so after calculating any quantity, we have to write down the unit. So here the unit of electrical flux is coulomb. So it is measured in coulomb. Now electrostatics. So what is electrostatics? Electrostatics and electrical field are electrostatic is a branch of science which deals with electricity at rest. We all know that an atom has equal number of electrons and equal number of protons. By some means we can increase the number of electrons or we can increase the number of proton so that the atom will be electrically charged. If we increase the number of electrons in an atom, so it is called negatively charged, and if we increase the number of protons or if we decrease the number of electrons, then the atom is known as positively charged. So we have different methods to charge an atom. Here is a perfect example. We have a piece of silk and a glass rod. If we are rubbing a glass rod with a piece of silk, then some materials like glass rod will attract protons, and the piece of silk will be negatively charged because the electrons are moving from glass rod to the silk by rubbing the glass rod to the silk. So after some time the silk will be electrically negatively charged and the glass rod will be positively charged. So here we can see that the transfer of charge is occurring. Now friends, we are going to see the fundamental laws of electrostatics. See, the fundamental laws of electrostatics are having two laws. The first laws show that like charges repel each other, whereas unlike charges attract each other. See, here we have taken two positive charge. They are like charges. So the electrical lines are oppositing each other. It means that the like charges are not attracting each other, but they are repelling each other. And here we have put a positive charge and a negative charge. So these two are unlike charges. So these charges are attracting each other. So the fundamental laws of electrostatic, the first law is that like charges repel each other, whereas unlike charges attract each other. The second law of electrostatic is the magnitude of force between two charged bodies. Okay, it is giving us the magnitude of force. So the magnitude of force between two charged bodies is firstly directly proportional to the product of the charges. It means F is proportional to Q1 into Q2. Q1 is first charge and Q2 is another charge. The product of these two charges is given as the force. So the force is directly proportional to the product of the charges. After that, the magnitude of force between two charged bodies is inversely proportional to the square of the distance between the centers of the charges. It means we can say that F is inversely proportional to D square, where D is the distance between Q1 and Q2. And the third thing is that the magnitude of force between two charged bodies depends upon the nature of surrounding medium. So this is the fundamental laws of electrostatic. Firstly, we have seen that like charges repel each other, whereas unlike charges attract each other. And the second law is the magnitude of force is between two charged bodies is directly proportional to Q1 and Q2, the product of Q1 and Q2, inversely proportional to the square of the distance between them. So we can say that F is proportional to Q1 Q2 by D square. Here we have put a constant called K. So F is equal to K into Q1 Q2 by D square and the force is measured in newtons, and where the K is Coulomb's constant and the value of K is 1 by 4 pi epsilon 0 and it is 9 into 10 raised to 9 Newton meter square by Coulomb square. Here I said that D is the distance between the charges and epsilon 0 is the permittivity of space. So here comes permittivity. What is permittivity? Permittivity is the ease with which it forms electric field. So if the permittivity of a material is high, then it will be conductor. Now we are going to see the characteristics of electrical lines of force. See, the electrical lines of force are having many characteristics, in which first comes the electric lines of force always originate on a positive charge and terminate on a negative charge. If you have taken the example of magnet, then the lines of force of magnet always originate from N and go to S pole. So here in electrical field, the electrical lines of force always originate on a positive charge and terminate on a negative charge. The second characteristics of electrical lines of force is they always leave or enter a conducting surface at right angles to it. It means that it will have a 90 angle if it is leaving a charge or it is entering a charge. The third characteristics is that they never cross or touch each other. The lines of force never cross or touch each other. And the fourth characteristics is that lines of force having the same direction repel each other, while those having opposite direction attract each other. So these are the four characteristics of electrical lines. First, we have seen that they always originate on a positive charge and terminate on a negative charge. After that, the angle 90, remember angle 90, so it will leave or enter a conducting surface or a charge at right angles. After that, the third characteristic is they never cross or touch each other, and then lines of force having the same direction repel each other, while those having opposite direction attract each other. Now, what is electric field intensity? Electric field intensity is defined as the ratio of the force F acting upon the test charge to the magnitude of the test charge. It means we can see that the electric field intensity E equals F by Q, where F is the force and Q is the charge. And we can also say that the electrical field intensity is V by D. It means volts per meter, where V stands for voltage and D stands for distance. This is electric field intensity. Now, electrical field density. So, electrical field density is defined as the flux per unit cross-sectional area emanating normally from the surface. It means D equals psi by A, where psi is the flux and A is the area, and the unit of electrical field density is coulomb per meter square, and the unit of electrical field intensity was volts per meter. Here, if we take a sphere, then the area of the sphere will be 4 pi r square, so that we can say that electrical field density D equals Q by 4 pi r square for a sphere, and the unit is coulomb per meter square. Now we will see the relation between electric field density and electric field intensity. We know that D is equal to Q by 4 pi r square coulomb per meter square, and we also know that E is equal to Q by 4 pi epsilon 0 epsilon r into r square, where epsilon 0 stands for permittivity of air and epsilon r stands for relative permittivity. We have already discussed about the permittivity and the role of permittivity. If the permittivity is high, then the force will be high, and if the permittivity is low, then the force will be low. So we can compare that epsilon 0 epsilon r E is equal to Q by 4 pi r square, but the Q by 4 pi r square is electrical field density D. So we can say that epsilon 0 epsilon r E is equal to D. So here we are having a relation between electrical field density and electrical field intensity, which is E is equal to D by epsilon 0 epsilon r, and the unit is Newton per coulomb. Now, what is electric potential? So, electrical potential is when a body is raised above the ground level. It possesses mechanical potential energy because of gravitational pull of earth. It means if we are raising a body, it will have some energy because of the gravitational force of the earth. So the electrical potential can be defined as the work done per charge, and the unit is joules per coulomb. Now we are going to see capacitors. From here we have seen electrical field, what is electrical field, and the basic terminologies of electrical field. We have seen electrical charge, we have seen lines of force, we have seen fundamental laws of electrical lines of force, and after that we saw what is electrical field intensity, what is electrical field density, and then we derived the relation between electrical field intensity and electrical field density. If you are referring a magnetic circuit, then you will also find there magnetic field density and magnetic field intensity. Now comes capacitor. Capacitor is a household device. Many times we have heard the name capacitor, and capacitor is used in many applications. So we have to understand what is capacitor. And capacitor is also a basic thing if you are going to learn electrical engineering. As I discussed earlier, that electrical field is very important, the basic thing if you are going to learn electrical engineering, and capacitor is also a basic thing to learn electrical engineering. So what is capacitor? So capacitor is defined as an arrangement where two conducting surfaces are separated by a layer of insulating medium. It means there are two plates and in which the dielectric material or insulator is given. So that arrangement is known as capacitor. So what capacitor does? Capacitor normally store electric charge. So capacitor has the ability to store the charge, and after that if it is storing the charge, and after that we can put capacitor in any application. Sometimes we call capacitor as condenser. A capacitor's capacity to store charge is measured in farads. So normally the unit of capacitance is farads. Now what is dielectric materials? It is very important to know about dielectric materials if we are going to see the capacitors. So dielectric materials, basically we can say that dielectric material is like an insulator, but there is difference between dielectric material and insulator. So the difference between dielectric and insulator lies in the application to which these materials are put. Both dielectric materials and insulators both are used in different applications. So there is difference in the applications. See, when dielectric materials are used to prevent the flow of electricity through them on the application of potential difference,